Hello everyone. This is in continuation to various problems what we are seeing in linear programming. We had already seen about economic interpretation of duality. Now in this video we'll understand how do we convert a primal problem, that is the original problem, to its dual, right? So primal to dual, how do we convert it? Question is, formulate the dual of the following linear programming problem. Maximize z equal to 5x1 plus 3x2, subject to 3 times x1 plus 5 times x2 less than or equal to 15, 5 times x1 plus 2 times x2 less than or equal to 10, x1 and x2 greater than or equal to 0. First step is to write down the standard form of the whole linear programming problem. Means the standard form of the above primal is, so in standard form, we again rewrite the same objective function. Then the constraints we incorporate here, both are having less than or equality sign. So we will incorporate a slack variable subject to 3 times x1 plus 5 times x2 plus 1 times s1. Second constraint, 5 times x1 plus 2 times x2 plus 1 times s2. Another slack variable that s2 is not there in the first constraint and s1 is not there in the second constraint. Now I can equate it to this 15 right hand side constant and 10. So whatever slack variables we introduced here, we will bring those in the objective function. So plus 0 times s1 plus 0 times s2 with 0 coefficient. Now I can rewrite the non-negativity restrictions as x1, x2. Apart from that, s1, s2, all are non-negative. Once we write the standard form, we will formulate the dual of this. Since the primal has two constraints, we have since the primal has two constraints, we will have two dual variables. Let the dual variables be, W1, W2. Okay. Now, the dual will be, if the original problem is maximization, dual will become minimization. Original problem has got Z, means here we will call it as Z star. Now we will have some coefficient times W1 plus some coefficient times W2. Now what will be those coefficients? It will be the right hand side constants of the primal. So this 15 and 10 will come here. 15 and 10 here. Now, subject to, what will happen? This two equations will be written as a transpose, means this 3x1 and 5x1, which is sitting in column, that will come in row, means 3 times, W1, not x1, because we will be writing dual variables. Just a moment. Three times W1 plus 5 times W2. Same way, is 5 times W1, second column, 2 times W2. Then 1 times W1 plus 0 times W2. And the last one, 0 times W1 plus 1 times W2. The original primal was having less than or equality sign. So here everything will become greater than or equal to. What will come in the right-hand side as a right-hand side constants? Whatever is written here in the standard form, the coefficients of objective function, that will come in the right-hand side. That will come as a right-hand side constants. So 5 and then 3 and then 0 and then 0. If you look into this, this can be simplified as W1 greater than or equal to 0. This is W2 greater than or equal to 0. We may notice that the last two constraints actually became non-negativity restrictions for the dual. So it is dual's non-negativity restrictions. And these are the dual constraints. And this is your dual's objective function. This is how we convert a primal problem to a dual problem. In case if you find the contents of this video to be useful to you, I request you to please like it, share it with your friends, and also subscribe to my channel. Thank you.